Hey, it's Austin. In this video I want to talk about the Subaru turbos that keep failing and how you can fix that problem and why it's happening. So the failure I'm talking about specifically is when you have a turbo that looks like this when it comes off. What happened here is this turbo did not get enough oil. However, it was getting oil, but it wasn't getting enough oil. So what happened to this one was that the bearings just wore out and eventually the shaft broke in it. It's not always that the shaft breaks and wedges in sideways. So what happens here, and I know that what happened with this one because this guy's put multiple turbos on it and I've seen this problem before. So there's 3 filters in the cylinder head on the Subaru engine. That includes the EJ20 and the EJ25. So, and maybe other models too. So those filters eventually get clogged up because of just small metal fragments. And the way to go about fixing that is you can remove the filters out of the head and the one that's above the turbo, which will prevent that problem from happening. However, you will have some dirtier oil going to the turbo, but dirtier oil is better than having no oil, because if you just keep on replacing the turbo, this will happen every time. Now, how do you know when you have that problem? Usually when you have a turbo that looks like this, it's because it wasn't getting enough oil. And what the turbo will do, the symptom is usually it'll just start to whine really loud like a siren. Now, there's another thing that could have happened in conjunction with this failure, which is if you had an engine failure problem prior, or you're going through it currently, or you put a dirty engine part onto your new engine or something along those lines, what can happen is that dirty oil, it could be have metal flake in it from like a spun rod bearing or something like that. Well, that dirty oil can go and clog those filters up, and then it just blocks the oil pressure off to the turbo. In this case with this turbo, it didn't necessarily block it off completely, it just severely restricted it. Now, sometimes, in some cases, what will happen is the turbo will start to act fine. It may be a little bit laggy at first, but over time it's wearing out, especially at higher boost levels, because when you're spinning that turbo faster, it needs more oil to be able to stay alive. However, if you just drove it normally, sometimes it will actually last a little bit longer. I had a case recently with a BMW. I didn't do this rebuild. He put a brand new turbo on a set of turbos. The rear oil line was slightly bent, like a little kink in it, and over 4,000 miles, the rear turbo finally went bad. I explained to this customer that, because him and his mechanic wanted me to diagnose it for him, so I explained to him that, yeah, the oil feed line was kinked, which would restrict the oil flow going to the turbos. Now, the mechanic said, well, he's running like 25 pounds of boost, he's abusing the turbos. Well, the front turbo is completely fine. If he was running too much boost, then the thrust bearing would have been worn out, and the front turbo and the rear turbo, but that wasn't the case. The turbo on the rear looked exactly like this turbo right here, and I know that it wasn't getting enough oil because what happened to it was it had a lot of side-to-side shaft play where the compressor wheel wore out, and not just in and out. If the turbo was run with too much boost, it wouldn't have wore out the journal bearings. It wears out the thrust bearing. So it wouldn't have had that side-to-side shaft play. It would have just had severe in and out shaft play. That's if you run too much boost for what the thrust bearing can handle. Usually you don't have that problem on the smaller turbos. You have that problem pretty commonly on a turbo that has a really heavy rotating assembly and not a strong enough thrust bearing and thrust washer and spacer to be able to support it. It's very common in this turbo that I'm showing you here. This one can have a thrust bearing failure if you don't have the correct thrust bearing for it, but only if you run 20 pounds of boost or more. But if you use the dual oil port thrust bearing with the brass bearing, then you won't have any problems. If you use a steel bearing, you're going to have some problems if you're not running the correct oil. If you use a brass bearing, you're going to be fine. And with that 2 oil port thrust bearing, you also need the wider collar, which is 18 millimeter. The factory one's only 14 millimeter. Because the 18 millimeter has a much more wider stance on the thrust bearing, it provides more durability to keep the rotating assembly in its place. This failure is the worst possible failure that you could have with a turbo in general, because in this case the whole cartridge needs to be replaced. The compressor housing can usually be sanded out like a couple times and then reused if you can buff out the scratches and stuff. The turbine housing, I might be able to reuse that if it's not too beat up, but the whole center cartridge needs to be replaced. So that's really the most expensive way, or one of the most expensive rebuilds, when you have to replace pretty much the whole turbo. In addition to that, the B&R series is even worse. It's not that the turbos are bad quality, it's just that they're much harder to repair because they don't use the original Mitsubishi bearing housing. They use like a combination of parts. Like they'll use a VF52 compressor housing, and then an adapter plate, then a special C-clip, and then the original bearing housing gets machined down to be able to fit that. So if you want to go back and fix that B&R 16G, you have to go back and take the original bearing housing, machine that down to be able to fit the compressor plate that they made, and then the VF52 compressor housing, which is extremely just annoying. I usually don't even like to mess with that stuff. I'd rather just replace the compressor housing, the wastegate, and then the whole cartridge, and just use the turbine housing from that B&R series turbo. Just to recap this video, it's the filters inside the cylinder head that gets clogged up that restricts the oil going to the turbo, which causes the failure. It's failing because it's not getting enough oil to the turbo to be able to cool it at higher boost levels. If you're just driving it around normally, it usually will last a while, especially if it's getting enough oil to operate in like non-boosting conditions or low boosting conditions. But if it gets to the point where it completely clogs up the filter, or clogs it up for a more severe amount of time, then the turbo will just go bad completely. Sometimes you won't even see it blow oil because it's not getting oil. Hopefully you learned something from this video. If you did, please pass it around with your Subaru friends, and I will catch you next time.